Listeners, good morning. This is Professor Ramesh Babu from SR University, Warangal, India. I welcome all the learners for this session on work breakdown structure as part of project management lecture series. In this session, we'll be learning about how to disintegrate the deliverables in a project through a systematic project management technique called work breakdown structure. In the earlier sessions, we discussed about basics of project management and project life cycle. Hope you have seen those lectures on YouTube. Now let us learn what is the definition of a work breakdown structure. So WBS is a fundamental project management tool which is used to decompose, divide, disintegrate, make into small portions, of project deliverables, project works, project work packages, divided into smaller and manageable components. When a project has got some 20 sub-assemblies, it's always good practice to identify expertise in each sub-assembly and deploy suitable manpower, location, area, materials, and team is allocated accordingly. To make this possible, it is required to divide the deliverables into manageable components so that work allocation, monitoring, and controlling can be done effectively. This also gives clarity on tangible outcomes, milestones, quick and easy monitoring, efficient monitoring, etc. So WBS outlines key features, inputs for the WBS, outputs of the WBS, advantages, rules, levels of WBS, etc. We're going to learn in this session. With the examples also, I'll be explaining about WBS. See the key features of WBS. It is a powerful tool for project planning and execution. It essentially divides complex project into smaller and more manageable units. So these units can be, tasks can be data, products, assemblies, sub-assemblies, sub-components, or services, or a complex tangible product and service. These units are organized hierarchically. So this is the most important aspect of WBS. These are organized hierarchically, with each descending level providing increasing detail. The typical WBS looks like a tree roots. The main root on the top, then sub-branches of roots in the bottom level. In the lowest level of the WBS, we'll find the work package, each sub-package, so which represent specific tasks that can be easily estimated and managed. We can plan tasks easily, estimate the requirements and costs easily for each subcomponent, and manage each one efficiently. A crucial aspect of the WBS is that it ensures traceability. When we divide one main project into sub-assemblies, now each sub-assembly is a specialized connected item. For example, an electromechanical project. An AI-based car is manufactured. The car runs on battery supply, power is from batteries. AI-controlled human-less car, for example. In that, the main deliverables will be the structure of the car, power supply, battery, etc., and electrical connections, all electrical engineering works, all mechanical engineering works, the steering system, AI-based control system and program and central control connected to server telecommunication network, all electrical sub-assemblies, the wheel assemblies, wheel and tire assemblies, then lighting power supply connections, then braking system. So like this, it is divided into subsystems Each one is expert area where we can allocate to expert team. And each subassembly is connected with their sub, micro, nano components. It is easy to trace out which belongs to what in case something goes wrong. So this traceability from the overall project scope down to the individual task, it is very much connected. Just to have a first hand idea, I'll just show one sample of WBS diagram. Here we can see on the top, it is the title of the project, Live Emotion Detection and Mode-Based Recommendation System. This is the project of one of my students. So under this, the tasks are divided. Project initiation and planning is one important task. Research and database preparation, another important deliverable. Model development, system integration, user interface and testing, deployment and feedback, documentation and final report of the project, then project monitoring and controlling are divided. Now, further, under user interface and testing 1.5, it is further divided into 1.5.1, 1.5.2, like designing of UI, the display of the systems like this. So each task is subdivided for easy understanding. So this means every activity within the project can be linked back to a specific deliverable. Now, the subcomponents at the bottom of the WBS, each one is connected to their respective deliverable. So this ensures that all work contributes to the project's objectives. Means clearly defined, all are connected. We make sure that nothing is missing. Then each one is monitored without any missing of element or task. There's no surprise in the end that something we forgot. Furthermore, components within the WBS should be deliverable oriented. So when we create this WBS, we should see that it gives a tangible output. That's called deliverable oriented. And these WBS tasks must be defined using active verbs. As I was telling about AI controlled, electric powered car. In that, if one task is about battery assembly, we must clearly write battery assembly in the WBS. We should not write simply battery. If we write battery, the particular team will not understand what to do with the battery. We should write assembly. Okay? Or connecting with the connectors. Or battery testing or performance measurement. So like this, we should use a verb to define what to be done with that particular element. So making it clear what needs to be accomplished. This is very important. So let us see what are the requirements to make a WBS, or what are the inputs required to create a work breakdown structure. The very first one is project scope statement. Because every project, when we make the project charter, first we make its scope. What all is covered in this project, including objectives and boundaries. So scope statement is a requirement before creating WBS. Then it requires documentation. To create WBS, documentation is required. The documentation only outlines all the project requirements and stakeholders' expectations on paper, so that no item is missed in the WBS. Then another input is enterprise environmental factors. One need to consider all the internal and external influences on the project while creating WBS. Then organizational process assets. Before creating WBS, we need to see the past data and that organization where the project is done, that organization's policies. What kind of policies are there for procurement, maybe for finance release, or for monitoring, or for approvals? We need to see that before creating a WBS. Now let us see in detail about each input. So project scope statement. So this is the document. This document defines the objectives, deliverables, the boundaries within which project is supposed to work, which are exclusions of this project, which defines the boundaries. So all these are providing the foundation for the WBS. Second input is requirements documentation. So these documents outline the specific requirements that the project must meet, ensuring that WBS is as per the expectations of the stakeholder, or at least in alignment with the stakeholders' expectations. This was the sample which we have seen. It shows you in a hierarchical manner. Top one is the main heading, then sub deliverables, then further components are divided under each subheading. Let us see the outputs of the WBS. When WBS is made, the outcomes or outputs of the WBS are, first one is the scope baseline based on which the WBS is created. The scope should be very clear, objective should be clear, boundaries must be very clear. From the document, this WBS is prepared. So final WBS reflects the boundary control scope only. And the WBS document is the final document available after making this WBS exercise. So this document is a visual representation of the project deliverables. Every team will have clarity of interconnectivity, what all they are on the picture, what all to be done in this project. Then WBS generates one dictionary, WBS dictionary, which explains each component's description. Each component, a battery, AI control system, steering system. For each one, there is an explanation in the WBS dictionary. So all the team members can refer to the descriptions whenever required. Then project documents updates. So this is to check changes to align with the project needs. That alignment this will show. Let us see the output components in detail. So the WBS process generates several outputs. First one is WBS document. So this document contains complete scope, broken down into smaller and manageable sections. And it also serves as a visual representation. The diagram which you have seen earlier, it gives a clarity to all the team members and the stakeholders. What deliverables which are connected to what and required to achieve them. All these people understand easily in the visual representation. And the WBS dictionary is the outcome. This provides detailed definitions, descriptions of each component within the WBS, including work packages and control accounts. So it clarifies the scope of each element. Each element scope is clarified here, ensures that everyone involved has a common understanding. This is the purpose of this WBS dictionary. Everybody should refer to this and a common understanding. No confusion. Documents updates. This includes updates to requirements, documentation based on approved change requests. Sometimes changes will happen based on the change control board's approval. Changes are made in the project. The change may be because of a request from important stakeholder or financier or customer or technology change, etc. So approved change requests are incorporated, ensuring that the WBS remains aligned with the evolving project needs. So changes, if required, to be done with approval of the change control board, accordingly in the WBS. Then scope baseline is another output. So this is a combination of the scope statement, WBS document, and dictionary. So these three together we call it as scope baseline. Anyone want to clarify any doubt during project execution will refer to scope baseline. What was the scope statement? WBS document and dictionary. That's all. So it serves as agreed upon scope of the project, and it is used as a benchmark for measuring progress and managing changes. Now let us see the importance of WBS or benefits or advantages of creating this WBS. The very first benefit is it simplifies the project definitely. Then having these WBS elements in detail helps in making estimation of resources, particularly sub-assembly, work package, what raw material required, what machinery is required, how many man hours required. So easy to estimate the resources for each element and combined in the end. So this WBS assists in setting milestone. When we have divided manageable subcomponents, it is easy to set the milestone for each. And also during this process, potential risks are identified early. And it also improves the project's efficiency. and it enables easy allocation of resources. It provides better understanding of stakeholders. It helps formulate the communication plans also with the stakeholders as per requirement. Now let us see the detailed advantages. Now these advantages contribute to the successful project outcomes. Very first one is it simplifies definition, organization, and management. So by breaking down complex projects into smaller and more manageable components, so WBS makes it easier to define, organize, and manage the work. It helps in project efficiency improvement because the things are streamlined. And while execution, there is a clear roadmap available on all the tasks and each component. There is a clarity for everybody where to do, what to do, in what quality, to whom to hand over. And it helps in estimating the resources like time estimation, cost estimation, manpower, staff requirement. Plus, we have the detailed breakdown. It enables easy allocation of resources. So the WBS permits the top managers to allocate resources to specific tasks and deliverables as per requirement exactly. It ensures that right people and right tools are available when needed, which is the benefit. If someone does without WBS, it will be a hazardous task. Or randomly things happen. There may be surprises and shocks in the end that something missed, something forgot, something delayed, mismatches. All this will happen if somebody is going with unscientific way of project management. So scientific project management will have a WBS in hand. So it also helps in setting milestones like identify key milestones. During this process, we identify which is the key milestone, which are the key milestones within the project. So and it provides opportunity to track the progress and celebrate achievements. Like milestone 1, the AI programming is done for the AI powered car. Now, once that is, several programs are made, tested, when it is completely done, so one important part is done. So it can be a milestone which can be celebrated as successful completion. Similarly, car body structure assembly. So like bending, fixing, cutting, welding, painting, all assemblies, the car body is ready. It can be a milestone. Then battery and components assembly can be one mile. Like that, an AI-based car can have 10 to 15 milestones. Then one will know clearly how much is happening, how it is getting completed successfully. Another advantage is it gives better understanding for the sales. It gives a clear and concise view of the scope, and it makes easy to the stakeholders. They understand clearly what are the objectives and deliverables. They can connect very easily. And WBS identifies risks early because the components are broken down. It helps identify potential risks and challenges even in the planning process itself. This helps in formulating the effective communication plans. And this helps stakeholders. They get information time to time on the progress or any issues that arise. Another important aspect of WBS is project managers must know about the rules of making WBS. Once the rules are clear in the mind, it is easy to make a WBS for any complex project. It can be making of a very big dam or an aircraft or a ship or maybe one mobile application. So the first rule is activities must be traceable to the project scope. Means when we are making activity list, we should see that these activities are connected to the scope only. There should be no activity which is not connected to the scope. Means we are trying to make within the boundaries. Every activity within WBS must be directly linked to the project overall scope and objectives. Second important rule is using active verb for each component. Means while writing WBS breakdown for each element, we should add a verb. Use an active verb to clearly indicate what action to be done, which is associated with each task. Suppose 2 steel rods to be fitted near the engine of the car. Now, if we write the steel rods, particular team member will not understand what to do with the steel rods, welding of the rods using this. That is the clarity of the by adding an active verb. Next rule is child components must fully represent the parent component. Now the parent component means the main deliverable. Under that we are dividing small tasks. So small tasks are called child components. The subheading, main headings are called parent components. As we can see in the diagram, I'll just refer to the diagram again. You can see here, the bottom green color components are child component. The blue color one is the parent component. The child components of a parent component must collectively represent all the work required to complete the parent component. If you're talking about mechanical assembly of this car, which example I'm taking now, all the mechanical elements, all 100% must be there in the child components list, which completely makes car body assembly ready. All electrical systems, including battery, ready. It's electrical. All steering system ready, including steering wheel, hydraulic mechanism, up to connected to wheels. All braking system, brake pedal, brake levers, then hydraulic mechanism or electrical mechanism, till the tire, how it is connected. So like this, each child component together under one deliverable connected, and it will clearly indicate that it is completely provided for. Another important rule is all components, the WBS components, must produce a deliverable. There should not be any WBS division which will not give a deliverable. Okay, so every component within the WBS should result in a tangible deliverable, whether it is a document, it can be a planning document, or maybe 120 drawings to be done by a draftsman, or it's a piece of software, small chunk of software, one sub-program, or a completed task or service. Anything can be a deliverable. Another important thing is WBS is not a time order. Means in the diagram, when we divide based on the main elements of the system, sub-assemblies, micro nano level assemblies and components only. So it need not be time order. Okay. When we say first sub-assembly, second sub-assembly, third sub-assembly in WBS, the third one need not be after completing second one. It is not based on the time of project execution. It is only to understand that which are connected to which parent element, which sub-assemblies are connected to which main assembly. Only to understand. So WBS focus on decomposition work, not the sequencing of tasks. So the sequencing comes later in the project planning process, and network analysis and scheduling we will learn sequencing. Another important rule is follow the 4+2 rule. Means when you're dividing one main assembly into a few sub-assemblies, see that it is not more than 6 sub-assemblies. Because each assembly or sub-assembly will be allocating to one team. Generally, humans, it is difficult if you are allocating 20 different items to one team. To keep minimum 4, maximum 6. This is easy for people to follow. Avoid having more than 6 nodes per layer. This we will discuss in the diagram to maintain clarity and manageability. Another important rule is WBS is progressively elaborated. And we are dividing main project heading into 6 or 7 divisions. We saw the blue colored second layer is main assemblies or work packages. From that again, we divided each work package into smaller work packages. So WBS is not static. It is progressively elaborated. More details are given in the bottom layers. So more information becomes available during the planning process. Another rule is avoid adding unnecessary details or obvious details. Means when we are making a statement in the WBS like battery, testing of battery is a task. Assembling of battery is a task. Integration of battery is a task. So this clarity is required while writing the element. Focus on including only the essential details necessary in the WBS. Need not be a paragraph explaining the purpose or description. It's only define the work. Don't make it complex, make it simple. Anybody should be able to understand by reading the component with verb. And 2 weeks rule. This may not be applicable for all projects. For the thumb rule, no activity should be smaller than 2 weeks of work content involved in it. Otherwise, there is no purpose of creating a separate team for it and deploying resources for them. And something is smaller than few hours of work, it can be added with the nearest subassembly. So it ensures that the tasks are substantial enough to be effectively managed. Something is substantial enough, then you allocate as a separate element. 8 by 80 rule means work at any level should not be less than 8 hours or greater than 8 hours. This is a thumb rule, may not be applicable for small projects. Typically, WBS consists of multiple levels. Like level 1 will show the overall definition of the project, which is highest deliverable. Means construction of a dam is the main heading. Then level 2, it will identify and define all deliverables on the construction of dam, excavation work, earthing work, concrete work, procurement work, electrical systems, mechanical. Like this, we divide the main deliverables. Then after that, level 3, divide the mechanical works like get the equipment, deploy the equipment, deploy the operators. Like this, we subdivide each one. Level 4 is breaking the activities into granular or sub-activities. Level 5 is more nano level. Okay, more details are given. The WBS looks like this. Here the project main title. Now here it is divided into several levels. Level 1 is the main title of the project. Under that, level 2 is 1, 2, 3, 4, 5, 6, and can be many. Now there is a clear numbering, unique numbering is allocated to this. Level 1, it is 1. Okay. Then level 2 comes 1.1, 1.2, 1.3, 1.4, 1.5 like this. Further level 3. So from 1.1 we further divide into 1.1.1 and 1.1.2. And when it goes to level 4, so 1.1.2.9. These are the numbers. 1.1.2.1 like that. So level 5 further. So this is how the WBS numbering is allocated and unique. Now this 1.1.1.2.12, 1.1.2.9, all this together makes a 1.1.2. And 1.1.1 and 1.1.2 together will make 1.1. All this 1.1, 1.2, 1.2, all this together will make 1. This is how connected. Child elements connected to the parent element. And in each rectangle, there should be the task with the verb that we are going to see in the next slide. Here we can see this is level 1, means 1.0. Live emotion detection and mood-based recommendation system of the project. Under this, we have divided tasks into 8 tasks. First one is project initiation and planning, which is 1.1. And research and database preparation is 1.2. Model development 1.3, like this. Now, under 1.1, we subdivided further into 1.1.1 into 1.1 into 1.1.1, 1.1.2, 1.1.3, like this. Means we clearly understand. If you see 1.1.3, we understand that this is connected to 1. Similarly, somewhere we have 1.5.3. We know it belongs to 1.5. User interface testing. So this element, a team working on 1.5.3 knows that their child element is connected to the parent element 1.5. This clarity will be there for all the sub-assembly and subgroups. That is the benefit of having WBS. Now let us see this, how this numbering is allocated, how the child components are connected, how the assemblies and sub-assemblies are made for the deliverables. This one is the first level, which is the title of the project. Then under that, there are all the green elements are second level. 1.1 is second level. 1.1.1 is third level. If something is beyond that, suppose under 1.1.1 we have 3 elements. You can create 1.1.1.1, 1.1.1, like that. Okay. Based on these numeric numbers, we clearly identify what level this belongs to. Okay. And it belongs to which main heading. So here we can see under project initiation and planning, there are 4 components of level 3. This is level 1, this is level 2, and all these are level 3. So in this planning initiation stage, we define the project objectives and success criteria. Point 1.1 is allocated to 1 member or 2 members or 10 members to create this. Then another task under 1.1 is analyze the teams and roles. What is the task deployment activity? 1.1.2. Then identify hardware and software requirements. Another document. Then develop project timeline and risk analysis. Another document. 4 documents are already under initiation and planning stage. This is one main assembly. Then second main assembly is 1.2, which is research and data set preparation. From the diagram, these are drawn again here. Under data set and research preparation, first third level is 1.2.1, means under this research emotion recognition techniques are done. Evaluate existing models, that is another task. Using some computer models, collect the data sets like this, several elements. So let us see the assembly 1.3, which is a model development. Under this, 1.3.1 is design the neural network architecture, load and pre-process data sets for training, train the model, validate and test model accuracy, optimize model performance, save or export model for integration. You can see each task is associated with active verb, and each child component has got a numbering. Here we can say up to level 3. Similarly, 1.4 is another assembly or chunk of the main project. Under that, system integration is done. Set up the real-time webcam video capturing, integrate trained emotion detection, develop mode-based. So music recommendations. So there is a clarity of what is to be done with that task. Then 1.5, which is the further work in the project, like user interface and testing. Under this, design the UI, user interface, display emotion and suggested content, the user interaction elements, conduct functional testing, performance and latency testing, debugging and UI refinements. So there are 6 sub-elements under 1.5. Now let us see another main assembly. There is 1.2 deployment and field. Under this again, there are 5 elements. Under 1.7, we can see 4 elements of level 3, which talks about final report and documentation. Then the last one is project monitoring and controlling. So weekly progress tracking, milestone review of each phase. So like this, there are 4 sub-elements. Now let us summarize this session. So a work breakdown structure is a deliverable-oriented hierarchical decomposition. Hierarchical decomposition, progressively elaborated from the top to bottom of a project into smaller manageable units, helping in defining, organizing, and controlling the total scope. So WBS helps in improving efficiency. More important is resource allocation, communication, and risk identification. So before closing, I would like to tell the WBS rules again so that it is useful for all the learners. What are the rules? Let us recap. First one is every activity must be traceable to the project scope. There should not be any element which is beyond the scope of our work. Suppose if a project is making of a multi-storied complex of 20 cinema theaters in one complex. Now, there is a piece of land, there is a borewell available. Now, the project scope is defined with the making of the several floors, building and electrical mechanical systems. But borewell digging is not included in this project work. So one should not simply assume that borewell and put it there. Already it was there and it was not asked for. It is not in the boundary of our project work given. Clear? It is an exclusion list, in fact. So this clarity is there. Like every activity connected. There should not be any activity just added because of fanciness of the people or project planners. They should not add because of their they like it to add. It should be as per the from the scope only. Everything should be collected to only scope. So every activity within the WBS must be directly linked to the overall scope and objective. There should not be any element which is not linked. And use active verb for every component. Clarity, assembling of this, transportation of this, deployment of this, connecting this, moving this, printing this, storing this. So there should be active verb. Third rule is child components must fully represent the parent component. Means the diagram we can see from level 2 to level 3 when we go, or level 3 to level 4. The bottom components must fully represent parent component. If I am writing battery assembly as one sub-assembly, under that, all the components required for the battery must be complete. We should not forget something. So the child components of a parent component must collectively represent all the work required to complete the parent component. So one should be cautious, making it complete means complete. Then all components must produce a deliverable. It should not be, intangible or not measurable. It should be measurable outcome. It can be a simple document also, planning document, a drawing made, a design made. Designer should not say, I have imagined and it is there in my mind, I'll execute. No, it should be in a computer aided design, CAD or AutoCAD or in a drawing shape, so that people can see, others can see and refer to it. Or it can be a part of software, an algorithm, or a flow chart, or code, or anything, or an assembly of mechanical, electrical, civil, electronic, any nature. And we need to remember that WBS need not be time ordered. Time ordering is done in critical path method and part analysis in project scheduling. So sequence is not decided here. We just make total list without leaving any component, okay, with it for the scope to complete. So WBS focus on decomposition of the work, not the sequence. Another rule is follow the 4+2. Try to divide into 4 to 6 tasks. Suppose there is one sub-assembly which has got 40 subtasks. Now try to group that 40 into 5 different categories. Put under that heading. That's all. Then WBS should be always progressively elaborated. As we go down to top level, level 1, 2, 3, 4, 5th level, more details are available for people to understand easily. Avoid adding any obvious things. Include only which things are necessary to define the work. 2 weeks rule is not applicable for all the projects. Maybe for big projects it is acceptable. No. Applicable where the project time is more than 1 year. 8/80 rule, minimum 8 hours task and 80 hours, maximum task may be useful for some project. These are the levels of the WBS. Level 1 should show project definition. Level 2, deliverables. Level 3, decompose the deliverable. Then high level to low level. Then level 4, break down into small or micro level. Level 5 is nano level, if required further. So this is the sample to see. Here you can see how these are divided, numbering is allocated. Here we can see in a table form all the components clearly mentioned with the verb. With this, I'll be closing this session. Thank you very much. Learners can give their comments for improvement in future. Thank you so much.